In this lesson, we're going to discuss how to solve perfect squares equations. By the end of this lesson, you should be able to solve equations involving perfect squares. When we factor a perfect square equation, remember that the factor that we're getting is repeated. So we have these repeating factors. When we have repeating factors, there's only going to be one solution because the binomials that you have are the same. So when you set either one of them equal to 0, you're going to end up with the same answer. When we're dealing with perfect squares and perfect squares equations, a property that comes in handy is the square root property. Remember that the square root is the inverse of a squared, and when we take the square root of a number, there are two roots, one that is positive and one that is negative, such as the square root of 9, which has a solution of positive and negative 3. When we're writing our solution set, it's going to be expressed as plus or minus a number within the braces. When we solve equations, when we solve polynomial equations, remember that one of the things that we have to do first is factor. So we factor out the GCF, that's the first thing we always want to do, and then we look at the number of terms that's left. If there are 4 terms, then we would factor by grouping. If we've got 3 terms, then we would use product sum or MAC or guess and check. And then if we have 2 terms, and they're both perfect squares, and they're subtracted, we could use difference of squares, or what we've just talked about, which is perfect square trinomials. Those last two, the difference of squares and perfect square trinomials, remember are shortcuts for factoring. Let's look at the following examples. So if we have example number 1, where it says solve the equations using repeated factors. So I know that x squared plus 22x plus 121 is a perfect square, because we take the square root of x squared, that gives me x, we take the square root of 121, that's 11, and 11x times 2 gives me 22x. So I know that 11 plus x is, or 11, I know that x squared plus 22x plus 121 is a perfect square. So when we factor, remember it's going to be that repeated factor, so x and 11, and then to get the sign in the middle, we look at that middle term, so that'd be plus. So that's x plus 11 squared is equal to 0. That's what we get when we factor. Now, because x plus 11 squared is really x plus 11 times x plus 11, and that's a repeated factor, when I solve this, I don't have to set both of them equal to 0 because it's the same thing. So I'm going to set one of them equal to 0. So x plus 11 equal to 0. I solve it, and I get x is equal to negative 11. So my solution for this one would be negative 11, and just have one answer. When we look at b, again, this is a perfect square. Recognize that I do have a fraction here, but remember fractions that are perfect squares. So 1/4 is a perfect square. The square root of 1/4, remember, is 1/2. We take the square root of the numerator and the square root of the denominator. So if I square root the first term, that's x. If I square root the last term, that's 1/2. And so we have x and a half. And 1/2 x times 2 is 1x. So I know that this is a perfect square. So when I go to write my factors, it's going to be x minus 1/2, because the middle term is subtraction, squared is equal to 0. Again, we have repeated factors here. So I'm going to set one of them equal to 0 since they're the same thing. And when I solve it, I get x is equal to 1/2. Now, our other option for this one is if we don't want to deal with the fraction. So let's say I really don't remember that 1/4 is a perfect square, and I don't want to deal with the fraction, then what I could do instead is multiply both sides by 4, which would clear the fraction. That would give me a new equation of 4x squared minus 4x plus 1 is equal to 0. And this also happens to be a perfect square. Square root of 4x squared is 2x. Square root of 1 is 1. And 2x times 1 is 2x times another 2 gives me 4x. So I know that that's a perfect square. Again, this time it's going to be 2x minus 1 squared is equal to 0. Again, I don't need to set both of the factors equal to 0 since they're the same. So if I set 1, that'll be enough. So 2x minus 1 equals 0. When I go to solve, that gives me 2x is equal to 1. X is equal to 1/2. So I still end up with the same solution. In the solution set, remember we're writing it as x, or as 1/2 inside of the braces. Now if we look at C, before we solve this one, I'm going to need to add 8 on both sides. Okay, I'm going to clear off a little bit of my work off to the side, that way I have a little bit of room here. Alright, so add 8 to both sides. What I'm going to end up with is 4x squared plus 12x plus 9. Again, recognize that this is a perfect square. Square root of 4x squared is 2x. Square root of 9 is 3. 2 times 3 is 6. And 6x times 2 is 12x. So I know that that's a perfect square. So my factors for this one are going to be 2x plus 3, because the middle term is added, squared is equal to 0. When I'm solving this one, remember I don't have to set both of them equal to 0, just one, since they're the same. So I get 2x is equal to negative 3, or x is equal to negative 3 over 2, which is negative 3 halves. And we put that inside of braces. Now, using difference of squares, I could solve this equation using a difference of squares. Remember that difference of squares wants us to rewrite it as the product of a sum and a difference. This is when we have a perfect square being subtracted by another perfect square. We take the square root of the first term, so that would be a. We take the square root of the last term, which is 8, and we write that as the product of a sum and a difference. And so if I'm solving the equation using difference of squares, I would set each of them equal to 0 because they are teeny bit different. One has addition, one has subtraction. I would solve. So I get a is equal to negative 8, or I would get a is equal to positive 8. And so our solution set would be negative or positive 8. Now, we could also solve this using the square root property. So if I'm using the square root property, my steps would be to get 64 to the other side. So instead of getting everything on one side, we would get variables on one side and everything else to the other side. So I'm taking a squared minus 64, and I'm going to add 64 on both sides. So that 64 moves over to the other side. That's going to give me a squared is equal to 64. The square root property says solve this equation by taking the square root of both sides. So I take the square root of both sides, and I get a, so the square root of a squared is a, is equal to the square root of 64. Now remember, the square root of 64 is both positive and negative 8. So we want to make sure that we write down both of them. And so by taking the square root, you just need to remember that the square root of any number is a positive number and a negative number. So when we take the square root of 64, we're getting positive or negative 8. So my solution would be plus or minus 8. Let's look at it again. So here we're solving the square root property given the giving repeated factors. So instead of foiling this out, moving 25 over to the other side, we could simply solve this using the square root property. So remember, the square root property says to take the square root of both sides. So I would take the square root of a minus 7 squared. Remember that a squared and a square root cancel each other out, so what I'm left with is a minus 7. And we take the square root of 25, which is plus or minus 5, because the square root of 25 is positive or negative 5. Now, for this one, I'm actually going to split it up so that I get both of my answers here. So I have a minus 7 is going to be equal to positive 5, but I also have a minus 7 is going to be equal to negative 5. So it's equal to both positive and negative 5. And then we can solve it. So I solved this one by adding 7 on both sides. That's going to give me a is equal to 12. And then I do it again by adding 7 on both sides. But this time, because I'm adding it to negative 5, it's going to give me positive 2. And so my solution for this one would be 2 and 12. Okay, let's take a look at this again. So remember with the square root property, it says if I have perfect squares on both sides, and I do, then I can take the square root of both sides. And honestly, I don't have to have a perfect square on both sides, but if I'm trying to get rid of a squared, I take the square root of both sides. So I want to get rid of this a plus 3 squared. I want to get rid of the squared on the a plus 3. I don't want to FOIL. I don't want to break it up into repeated factors. I just want to get rid of the exponent. So we square root both sides. The squared and the square root cancel each other out on the left side, so that leaves me with a plus 3 equals to plus or minus the square root of 16, which is 4. So I subtract 3 on both sides. Actually, let's split it up first. So a plus 3 is equal to positive 4. A plus 3 is equal to negative 4. And then we'll solve. So subtracting 3 on this side, I get a is equal to 1. Subtracting 3 on this side, I get a is equal to negative 7. And so my solution for this one would be negative 7 and 1. All right. We also know that it's not always going to start off as repeated factors. So notice that we have a perfect square trinomial on the left. So I'm going to factor that. Again, take the square root of the first term. Take the square root of the third term, just 2. And 2x times 2 gives me 4. So I know that this is a perfect square. It's going to be subtracted. It's going to be separated with subtraction because the middle term is being subtracted. And so when I rewrite this, what I have is x minus 2 squared is equal to 9. Now from this part, we can use the square root property. So on the square root property here, if I took the square root of both sides, that would get rid of the exponent here, so I'd be left with x minus 2. And the square root of 9 we know is plus or minus 3. And so this allows me to solve this equation as x minus 2 equals to positive 3, and x minus 2 is equal to negative 3. Add 2 to both sides. X is equal to 5, or x is equal to negative 1. And so my solution here would be negative 1 and 5. Okay, let's look at it again. So again, recognize when it's a perfect square. So this says take the square root of the first term, which is 2x. Take the square root of the third term, which is 3. 2 times 3 is 6, and then if I double that, that gives me 12. So I know this is a perfect square. Addition is going to be in the middle because we're adding that middle term. Squared is equal to 36. I can square root both sides to solve this, so I'm using the square root property here. So take the square root of both sides. The squared and the square root will cancel out, so that leaves me with 2x plus 3 is equal to positive or negative 6. And then again, we're solving this. So that says I can solve the equation 2x plus 3 equal to positive 6, or 2x plus 3 equal to negative 6, and then we solve. So when I subtract 3 on both sides, that gives me 2x is equal to 3, x is equal to 3 halves, or subtract 3 on both sides here, get 2x is equal to negative 9, so that means x is equal to 9 halves. And so my solution here would be negative 9 halves, or positive 3 over 2. Now, what do we do when we use the square root property, but the right side is not a perfect square? Well, we'll leave the radical sign for this particular one. So again, we'll take the square root of both sides. All right, oops. Let me redraw this radical sign for us. Okay, so take the square root of both sides. Again, the squared and the square root will cancel out, so it leaves me with m minus 4 is equal. Because I can't take the square root of 3, because it's not a perfect square, we're just going to write plus or minus the square root of 3, because we know that we could have the positive square root of 3 or the negative square root of 3. And then we would add. So I'm going to solve the equation. Here, I can solve it one of two ways. I can break it apart. I can do m minus 4 is equal to positive square root of 3, or m minus 4 is equal to the negative square root of 3, and then solve it like normal. So add 4 on both sides. That would give me 4 plus the square root of 3, or m is equal to 4 minus the square root of 3. We put the radical part at the end, or when I add, I could just leave it as m is equal to 4 plus or minus the square root of 3. When you're writing it in braces, the simplest form, the way that you're probably going to see it, is 4 plus or minus the square root of 3. But do recognize both ways. On this one, we're going to have to factor. So again, this is a perfect square. So take the square root of the first term, which is k. Take the square root of the last term, which is 1. We're adding because it's plus 2k in the middle is equal to 7. For solving using the square root property that says, hey, square root both sides, the square root and the square will cancel each other out, leaving you with k plus 1 is equal to plus or minus the square root of 7, since we can't take the square root of 7. Adding or subtracting subtracting 1 on both sides here is what you're going to need to do to get k by itself. And so what you would end up with is k is equal to negative 1 plus or minus the square root of 7. This is how we solve equations that involve perfect square trinomials.